Okay, hey everyone. So we're back for day 3, and day 3 is going to be covering the DevOps lifecycle, and again we're going to be focused on that application, so application focused. So basically, what I'm doing during these videos, if you're new around here, we started off with day 1, we've done day 2, now we're reading through day 3. At this first section, we don't really get any hands-on, but I expect that we can bounce into a terminal. We can do some stuff here as well later on. These first few videos have been quite short and sharp, like around that 10-15 minute mark, so I don't expect this one to be any different to that. But when we start getting into things like the programming language and Linux and networking, then maybe we want to start actually doing some stuff. But let me know whether that works, or whether you just want me to like read these out, or would you prefer a complete section at a time, or these individual videos. Let me know. A few of you have commented already. So DevOps lifecycle, application focused. So as we continue through these next few weeks, we are 100% going to come across these titles: continuous development, testing, deployment, monitor. Over and over again, if you're heading towards the DevOps engineer role, then repeatedly will be something that that doesn't make sense. We'll have to fix that. Will be something you will get used to, but constantly enhancing each time is another thing that keeps things interesting. In this hour, we are going to take a look at the high-level view of the application from start to finish, and then back around again like a constant loop. Okay, so look, we're going to touch on each of the... Everyone's seen the continuous DevOps loop. I'm sure there's probably a picture in here somewhere as well. Probably not. But everyone's seen... Oh. A good little plug for DevOps days. Yeah, everyone's seen something like this. So this is really what I'm going to cover in this. Maybe not so much detail. It's quite a nice one. I like that operate and the virtualization, containerization. But anyway, so firstly, development. So let's take a brand new example of an application. So we've decided as a business we're going to start doing this. To start with, we have nothing created. Maybe as a developer, you have to discuss with your client or end user the requirements and come up with some sort of plan or requirements for your application. We then need to create from the requirements our brand new application. Seems simple. In regards to tooling at this stage, there is no real requirement here, other than choosing your IDE and the programming language you wish to use to write your application. Now, as a developer, you probably know what language you're going to be writing in. Like if you're a Golang developer, or C++, or Rust, or blah blah blah, you're gonna or JavaScript, you're gonna know that, right? You know what your skills are. You know where you're gonna go. As a DevOps engineer, remember, you're probably not the one creating this plan or coding the application for the end user. This will be a skilled developer in one of those areas, you'd hope. As a DevOps engineer, no, done that. But it also would not hurt for you to be able to read some of the code so that you can make the best infrastructure decisions moving forward for your application. Like, spoiler alert here is that from a programming language point of view that I cover, and I think I mentioned this in another video, is that I chose Golang mostly because Golang is being used across the cloud native ecosystem, but equally the product that I'm very focused on within Veeam is also written in Go. Now, I'm not going to become a Go developer, or at least not very quickly, it seems. But I wanted to be able to read some of that programming language. Anyway, we previously mentioned that this application can be written in any language. Importantly, this should be maintained using a version control system. This is something we will cover also in detail later on, and in particular, we'll dive into Git. Everyone's heard of GitHub, GitLab, and the tool in which we'll use to version control our applications or our test environments is Git, which is available on Mac OS, Linux, Windows, etc. And that's going to enable us to keep a control of all the versions of our code base wherever that needs to be. It is also likely that it will not be one developer working on this project, although this could be the case. Even so, best practice would require a code repository to store and collaborate on the code. This could be a private or public and can be hosted or privately deployed, generally speaking. You would hear the likes of GitHub, GitLab, Bitbucket, etc. being used as a code repository. Again, we'll cover these as part of our section on Git later on. Secondly, we have testing. At this stage, we have our requirements and we have our application being developed. But we need to make sure we are testing our code in all the different environments that we have available to us, or specifically maybe to the programming language chosen. This phase enables QA to test for bugs more frequently. We see containers being used for simulating the test environment, which overall can improve on cost overheads of physical or cloud infrastructure. This phase is also likely going to be automated as part of that next area, which is continuous integration. The ability to automate this testing versus tens, hundreds, or even thousands of QA engineers having to do this manually speaks for itself. These engineers can focus on something else within the stack to ensure you are moving faster and developing more functionality versus testing bugs and software, which tends to be the hold up on most traditional software releases that use a waterfall methodology. Okay, so that's the first key area where someone that is looking to get into DevOps is going to have a lot more say in how do we automate that? How do we continuously integrate integrate our software and test that things are good in an automated fashion rather than having humans or feet that actually run through that process. Integration. Quite importantly, integration is at the middle of the DevOps lifecycle. It is the practice in which developers are required to commit changes to the source code more frequently. This could be on a daily or weekly basis. I've seen some even more aggressively, down to multiple times a day. With every commit, your application can go through the automated testing phases, and this allows for early detection of issues or bugs before the next phase. Now, you might at this stage be saying, but we don't create applications, we buy it off the shelf from a software vendor. Don't worry, many companies do this and will continue to do this, and it will be the software vendor that is concentrating on the above three phases, but you might want to still adopt the final phase, as this will enable for faster and more efficient deployments of your off-the-shelf deployments. I would also suggest that having this above knowledge is very important, as you might buy off-the-shelf software today, but what about tomorrow or down the line? Next job maybe? And the key part there is that I think I mentioned this as well before, or I mention it a lot, is that not every business at the moment, and there's a caveat there, is a software development house. Not everyone has that requirement and responsibility of creating software for end users, for customers. A lot will still just take it off the shelf. Now, where I feel that we've come into an era of SaaS-based workloads where it's just easy to give a credit card and use that, the key takeaway there is that there is always going to be that requirement to run your own software as well. And you still might want to be worrying about testing, because you'd want to test every layer of that as well. So there's some of this I think we all should be familiar with. Okay, deployment. Okay, so we have our application built and tested against the requirements of our end user, and we now need to go ahead and deploy this application into production for our end users to consume. Okay, so we're at the point now where version 1 or 0.1 is ready. This is the stage where the code is deployed to the production servers. Servers, containers, yeah. Now, this is where things get extremely interesting, and it is where the rest of our 86 days dives deeper into these areas, because different applications require different possible hardware or configurations. This is where our application configuration management and infrastructure as code could play a key part in your DevOps lifecycle. It might be that your application is containerized, but also available to run on a virtual machine. This then also leads us onto platforms like Kubernetes, which would be orchestrating those containers and make sure you have the desired state available to your end users. Of these bold topics, the ones that I emphasized above, we'll go into more detail over the next few weeks to get a better foundational knowledge of what they are and when to use them, versus just using them for using sake, which a lot obviously we do here because we don't have a particular scenario. Monitoring. Okay, so we've got everything up and running. Things are moving fast here, and we have our application that we are continuously updating with new features and functionality, and we have our testing, making sure no gremlins are being found. We have the application running in our environment that can be continually keeping the required configuration and performance. But now we need to be sure that our end users are getting the experience they require. Here we need to make sure that our application performance is continuously being monitored. This phase is going to allow your developers to make better decisions about enhancements to the application in future releases to better serve the end users. This section is also where we are going to capture that feedback wheel about the features that have been implemented and how the end users would like to make these better for them. Reliability is a key factor here as well. At the end of the day, we want our application to be available all the time it is required. This then leads to other observability, security, and data management areas that should be continuously monitored, and feedback can always be used to better enhance, update, and release the application continuously. Some input here. So Edin, good friend of mine in the community, some input from the community here, specifically Edin, mentioned also part of this continuous process, we should also have the FinOps teams involved. So FinOps being financial ops, looking at money, looking at how we can be better from a cost management and optimization perspective, especially when you're using cloud-based services. Apps and data are running and stored somewhere. You should be monitoring this continuously to make sure if things change from a resources point of view, your costs are not causing some major financial pain on your cloud bills. I think it's also a good time to bring up the DevOps engineer mentioned above, albeit there are many DevOps engineer positions in the wild that people hold. And this goes back to my last video where I was giving it a lot of air quotes. Albeit there are many DevOps engineer positions in the wild that people hold. This is not the ideal way of positioning the process of DevOps. What I mean is, from speaking to others in the community, the title of DevOps engineer should not be the goal for anyone, apart from it seems to get everyone a bit more cash. Because really any position should be adopting the DevOps principles and processes and the culture explained here. DevOps should be used in many different positions such as cloud native engineer, architect, virtualization admin, cloud architect, cloud engineer, and infrastructure admin, systems administrator as well. We could add in there a lot more. I think since I wrote this, there's been a lot more buzz around platform engineering. Maybe that's a better term. I don't know whether it's, I'm not going to get into that. Let me know what you think. This is to name a few, but the reason for using DevOps engineer above here in this whole premise, the whole content, for using DevOps engineer above was really to highlight the scope of the process used by any of the above positions and more. Again, I've added some resources here. There's a couple of things that I mentioned, a lot about continuous integration and development. There's two really good videos, continuous monitoring, the FinOps Foundation, what is FinOps, if you wanted to know. I'll also give a shout out to a not free resource, but well worth it if you're just starting, is the Phoenix Project. Great book. Bit slow to start, I thought, but that's maybe because I had some of that fundamental knowledge already. So yeah, really good. Again, if you've got additional resources that we should use, then by all means submit a PR and we'll get them in there. Yeah, with that, I think we're probably good to close this out, and I'll see everyone on day 4.